We'll be looking at numerical integration again, but we will focus on the inbuilt functions of Octave for numerical integration. So we won't be implementing any of the functions for this particular video. We'll just be using the ones which is already provided by Octave or Matlab. Okay, so let's start with a simple one. Before that, there are two ways you can calculate integrals in Octave. One is symbolically, the other is numerically. Symbolically is what you do by hand, right? For example, if you could define a function called x square and then you would want to know what its integration looks like in terms of symbols itself, you could do it by hand and you would come to know that it's x cubed by 3. But how will you ask Matlab to do it for you, or Octave, right? So for that you need something called you can define symbolic variables. These are different from your normal variables. You can define symbolic variables in Matlab or Octave. They're called sims. I mean, the way you define them is you type sims and then you type the variables that you want to define. So I want to define x and y, but this doesn't work by default in Octave because it's open source, things are free, so you have to work hard for some of the functionalities, but it is available. So for sims function, it says the warning says that it belongs to the symbolic package from Octave Forge, which you have installed and which you might not have installed on your system. So the first thing that you need to do is you can open up Google and search for Octave Forge. So these are so Octave comes with some default packages. If you want some extra functionalities, you can install them, and you can look up the functionalities or packages which have all these functionalities. You can look them up in Octave Forge and install them. So these are some of the ones which are there: Arduino, Audio, CGI, and all that. So the ones that we are interested in is where is it? Yeah, okay. It's not. Yeah. So the ones we are interested in is in symbolic. It says add symbolic calculation features to GNU Octave. So GNU means GNU is not Unix. It's a recursive acronym. Anyway, so symbolic. So in order to install the symbolic package, what you can type is something like this: pkg install -forge symbolic, right? But since I already have that, I'm not going to run this, but if you don't, then you can run it. And be aware that this might not work out of the box. Before you install this, you also need to have Python in your system. If you have Linux, you don't need to worry because they come with Python. If you have Windows, probably these days everyone talks about Python, so you probably have it in your system. If you don't, it's very easy to install using a package manager called Anaconda. So you can look it up, it's not that difficult. So if you have Python, then you can install this package symbolic, and then once you have installed it, when you open up Octave, this package will not load by default. So but what you can do is load it by yourself. So I already have this package in my system, the symbolic package. I need to load it. So I write package load symbolic, and now it's loaded. Now I can define a variable called x. So you wouldn't need to do all these things if you were running Matlab. You just type sims x and things work. Here, since it's free, you have to do some extra work by yourself. So you need to have the symbolic package installed, and for symbolic package to work, you need to have Python installed in your system. Anyway, so if you're using Matlab, you would start with this line. You can forget about all the things that I've said up until this point. So you type sims x to define a symbolic variable, then you define a function using this symbolic variable, which is x square, right? If you want to integrate this, now you can use a function called int, and you type f. So Octave integrates this for you. So same would be done by Matlab. So as you can see, it's x cubed by 3. So x square was quite simple to integrate, but if you have complicated functions and you may not know how to integrate them by hand, then you can use this function, right? You can use this function int to calculate the integration symbolically, right? But now we are mostly interested in calculating definite integrals, right? An integral between between limits a and b. So how would I do that? So I have for f, which is a symbolic function, right? if I need a anonymous function, or if I need a function which takes in some numbers and outputs some numbers, I have to define them with this, right? F at the rate x and something. Another way to do that is you can convert your symbolic function to Matlab function, or the function I talked about just now at the rate x. You can convert the symbolic function to that by passing them to this function called Matlab function. So if I pass in, let's call this new function fn function new. If I pass in my old function to this, it returns a Matlab function or an anonymous function. This is called an anonymous function. The difference between these two functions is this is a symbolic function, this function is in terms of symbols. This function will give you numbers if you input some number, right? If you write fn of 1, you get some number. If you write f of 1, you get nothing, because there's a symbolic function. It just returns the function. But if you type fn plus some number, then it'll evaluate this function at that number and give you back another number. Alright, so where were we? So if you define a symbolic variable, symsx, and then you define a function f of x square, then you can integrate it using the function, inbuilt Matlab function called intf. If you have a numerical function or a Matlab function which you would obtain by, or either you can write it by hand or you can just convert a symbolic function to Matlab, right? And then you can, what you can do is integrate that. But now you can't use int. Let's see, if I want to integrate this numerical function in between two and in between a and b, where a is 1, b is 2, let's say, this will work, but it's giving you answers in symbolic variables, right? This works, but it has evaluated your symbolic function between 1 and 2, and it has given you the value in symbolic variables. So okay, let me see if this works. Okay, this doesn't work. So anyway, so this when you input a symbolic variable and the limits, the answer obtained is a symbolic variable answer, 7 by 3. 7 by 3 here is not a number, although it is a number. The variable type is symbolic. If you want to convert it to numbers, you type double, so it takes in the symbolic variable and it outputs a double precision number, 2.333. Another way to integrate that would be, if you have a Matlab function, then you can use the function called integral, and that integrates and returns the value in double precision automatically. You don't need to convert from symbolic to double, right? Okay, the advantage of the earlier one was, for example, if you had some constants, then the answer would be returned in terms of constants. For example, if I define sims x c, where c is a constant, then I define a function x square plus c, and then I integrated this function between 1 and 2, 1 and 3, let's say, then I get an answer in terms of a constant, which I won't if I use the function integral. I don't, right? So if you use the integral function, then you need to convert this symbolic function to a Matlab function f, right? And now you can use your integral function between the two variables. Alright, so you would need to define so maybe I might be confusing you, but anyway, so it's c comma x, right? So I define some value of the constant comma x, and now it should work. I have defined c to be 1. Okay, you can forget about this particular line because it may be a bit complicated for you to understand. So for till now we have seen two functions, one was int and the other was integral. Now what if you have a function in two variables, right? Some function like what if you have a double integral? So I've already opened up an example for you to check. So if you have a double integral wherein the function is a function of two variables, so the function here is 1 plus x minus 1 whole square plus 4y square. So let's write that down, f is a function of two variables, 1 plus x minus 1 whole square plus 4 times y whole square, right? 1 plus x minus 1 whole square plus 4y square. If I want to integrate this function in between 0, 3 and 0, 2, where y goes from 0 to 2 and x goes from 0 to 3, I can use a function called integral 2. So I have not provided any input, so it has given me an error. It says it needs these inputs: the function, the value of x at a, and the x equals the limits of x and the limits of y, basically. So let me run it again. Let me input the function which I have defined already. What is my y limit? X limit 0 to 3, and the y limit is 0 to 2. Alright, so answer is 44, which is what you get. Now you can also have a triple integral, right? You can have 3 integrals. So how will that work? It's simple enough. First write the function. The function here is simple, it's just 1. So the function, which is a function of x, y and z, is just equal to 1 at all the values of x, y and z. The limits, okay, see here it's a bit tricky because the limit itself is a function. The first limit z, or the first one, x, goes from 0 to 1, that's okay. Y goes from 0 to x, y is a function of x, and z goes from 0 to 1 plus x plus y. So we need to define functions. So let us define these separately. I have already defined my function. Let me define xa. Let me define the limits basically. Xa is 0, xb is 1, ya is 0, yb, if you look carefully, it's a function of x which is equal to x. So yb is a function of x equal to x. Z a is 0 and zb is again a function of, look carefully, it's a function of x and y. So x comma y, and the function itself is 1 plus x plus y. Now you can use integral 3, input the function, then xa, xb, ya, yb, za, zb, and the answer is 1. Let's check. Yeah, it is indeed 1. So now I hope it's clear to you the inbuilt functions of Octave or Matlab. We saw one which was int, then integral 2, integral 3, right? So using these inbuilt functions you can calculate. There was one more. So if you have some values, right, if you have okay, right, so let me define a very simple function, x square, and let me ask Matlab to calculate the integration for me between 1 and 4. There's another function called trapz which calculates the numerical integration using the trapezoidal method. So what you pass to it is the value of x at which you want to calculate. So let me define some x between 1 and 4 with an interval of 0.1. Let me calculate the value of y at all these values of x, right? So I have done that. Now I can use trapz, which is the trapezoidal method, pass in the value of x comma y, and I get 21.005. If I decrease the subinterval size, I'll get better results, I guess. Right. Okay, I defined x again. Let me just, this is what I want, then y, and then trapz. So now I'm getting closer answers to the original one. So this is all we have for today. We saw int, integral 2, integral 3, and trapz functions, which are all inbuilt Matlab or Octave functions that you can use to calculate your integrations. When you don't want to do work by hand, you can use these. So thank you for watching, and I'll see you in the next one.